Good evening, everyone. Then it is 7:05 p.m. and we'll get going with our fourth of our six in the series for the Nova East COVID-19 edition. As many of you are aware, we would have had a star party this past weekend out at Smiley's, but due to circumstances that was postponed, or actually postponed until next year, I guess, in essence. And we will be having it next August, first weekend in August, I believe, is when it's scheduled for next year. But in the meantime, we have this incredible group of speakers that Dave Chapman has arranged for us for this year, and they've all agreed to give presentations. And this evening's presenter, Tony Schellinck, is no exception. So welcome, everyone. All the sessions are being recorded. So if at any point, for instance, during this session, you have to leave, not to fear, you won't miss anything. In about the next 24 to 48 hours, it will be posted on the Rask Halifax YouTube channel, and you can watch the full presentation there again. Or if you want to review it again, you can certainly do that as well. As I mentioned a moment ago, this is about Nova East. Certainly on our website, there is a Nova East website at novaeast.rask.ca, and I'll put these up on the chat line in a moment so you can copy and go to them when you wish. Also, for those of you that are from away, i.e. out of Nova Scotia, you will also note that there is national, through their what's happening at the Rask this week, posts this particular session each week, so that they can register through that means as well. One of the things that is part of Nova East is the Astro Imaging Contest. Now, as of 4 days ago, the contest has opened, so from August 21st until September 11th, midnight, you can certainly submit your astro images to the Nova East website, but there is a little catch here in terms of the astro imaging contest is limited to those who are residents of Nova Scotia or are members of Halifax Centre. So those of you who do not fulfill either one of those criteria, I apologize. But you can go to our site and enjoy the images.
It's not too late to join.
No, it's not. And so with that, now I'm going to try and share my screen here because I have a couple of things to show you. This is the t-shirt design that, by John Reed. He's one of our members, a recent graduate of SMU. And as you can see here, the original theme of our Nova East was March of the Planets. And no, we didn't design it so that everything was lopsided. The way the planets are arranged are the way that they would look this past weekend when Nova East was being held. So they are sort of all onto one side. But as you can see, it's COVID canceled. At least the star party is, but the physical party is. Yes, so that's that. But there is also a special announcement that I would like to make this evening to everyone. It's about one of our members. And there was a recent announcement about the winner of the 2020 Sky News Photo of the Year. This particular photo was submitted and won for the April for Photo of the Week. And one of the judges commented on it by saying, and I'm reading this, composition-wise, the Milky Way running parallel to the rocky shoreline with the softening of the water due to the long exposure, everything is just right there. So knowing how the judges felt about it, I think that Halifax Centre is extremely proud to announce that one of our Halifax Centre members, Jason Dane, took that photo of the Milky Way from Polly's Cove, Nova Scotia. And he won the annual Photo of the Year for 2020. So congratulations, Jason. He said, and I quote, another quote, he says, I was super happy to hear that I'd won the contest, and I was quite surprised to hear that there was a prize. I will be the lucky recipient of a Celestron AVX mount and an 8-inch Edge SCT that will be great to use for some smaller targets and for galaxy season this spring. Hopefully, as I develop my deep sky object photography and editing skills, I can enter some of those shots in future contests. Thanks to everyone for your support on my astrophotography journey. the details of how he took the picture in terms of what he took it with and the exposure times and whatnot, they will be listed in the most current edition of Sky News magazine. So well done, Jason, and we certainly look forward to a lot more images from you come the coming years. So you saw the logo on a black and white screen. So that's the design, what it might look like on a t-shirt. Okay. So if you'd like one, you can certainly go to the Nova East website and it'll tell you all about how you can own one of those if you so desire. So I think I've said everything I need to say at this point, but to reiterate something that Dave said earlier, certainly if you wish to become a member, it is never too late to do so. Just have to go to the ras.ca website and join.
Yeah, or you could jump ship.
Jump ship?
Yeah, you could change from your center to our center, so you can.
Oh.
or if you're an unattached, now called national member, you could join our center and with all the benefits that entails.
That's very true. But on that note, in any case, I will hand it now over to Dave Chapman and our moderator for this evening's session, and he will take it from here. Thank you, Dave.
Thank you, Judy. I just wanted to say one thing about Jason. I was chatting with him earlier, and he said he admitted that he didn't actually own an eyepiece. So I think we should pass the hat and get him an eyepiece for his new telescope so he can actually look at something rather than just take pictures. So.
Wow.
Anyway, it's my great pleasure to introduce tonight's speaker, Tony Schellinck. And the reason I say that is because he's a very exceptional member of our center. Compared to me anyway, he's a latecomer to amateur astronomy. I don't know exactly when he started, but it was recent. But he's made up for lost time. He got quite involved in the Halifax Center. He was the Nova Notes editor for a couple of years. He was a director of the Halifax Center Board of Directors. He's a natural born teacher, and you can't stop him from teaching. So he's come up with all kinds of innovative ways to bring astronomy to the general public, things that are quite innovative, like his ACE Amateur Astronomer program, which you can find online at the RASC website, the binocular table that he's had at Nova East and the dark sky weekends at Keji, and the telescope plaza. So he's done a number of things in that score. He's certified, not the way you might think. He is certified. He earned his Messier certificate in 2016, and then the Explorer of the Universe in 2017. An interesting order, I must say. And then he went on to do all 3 RASC Astro imaging certificates, all 3. The only other person I know who's done that is David Hoskin, who is also an RASC Halifax member. And like Alexander the Great, he had no more astro imaging worlds to conquer, and he wept. But it didn't stop him. He kept on going. He's rare, I think, in that he has a foot firmly planted in both observing and imaging camps. Usually people go one way or the other, and he's done both. And that's quite rare, I think. And his latest undertaking is I know he's sketching, and I think he's probably doing the finest NGC, not if that's correct.
That is correct.
And getting back to his teaching, he's quite involved with the Seniors Association of Nova Scotia. I think that's right, SANS, is that correct?
Senior College Association, SCANS.
And I would say that he has brought hundreds, if not thousands of people and introduced them to the joys of visual observing of the night sky. So he's been pretty busy. He's also been very involved with the Kejimkujik Dark Sky Preserve. He's down there a lot and is very interested in those activities. I just want to say personally, one of the memories I have with Tony is when we were at the Winter Star Party down in the Florida Keys one year when we were both there, and sitting outside, and I know people are going to groan when they hear this, sitting outside in February in our shorts and t-shirts, in our chairs, and perusing, combing through the hair of Berenice's hair, Coma Berenice's, looking for double stars. And I have this distinct memory of doing that with Tony. It was a wonderful night. It was one of those nights where you didn't dare go to bed because you were going to miss out. So we stayed up all night observing and paid the price for it the next day. That is my overriding memory of Tony. And the other thing about Tony is that you just never know what he's going to do next. Like, even though he told us what he was going to do, I'm sure we're going to be surprised. And so with that introduction, Tony Schellinck.
Thank you very much, Dave. That's very kind of you. I certainly appreciate it. All right. Can you see that?
It is
on the screen, Astronomy on the Cheap, the Summer Fall Challenge.
It is full screen now. Thank you.
It's good?
Yes.
Yay. Things might be a little slow. I'm out in the middle of nowhere in South Shore of Nova Scotia, and we have about the slowest internet speed that you can get, but we're hoping it'll work. And we've done a workaround so that Judy will be playing one of the only video that I have. Now, 3 nights ago, myself and my son-in-law, Colin Hanine, were out at our cabin, which is just 20 minutes away from Kejimkujik National Park. And it has the darkest skies on mainland Nova Scotia. And I'm putting up a new observatory there. And so we were sitting at the observatory site. He had his camera set up and I had my pair of binoculars. And so it was a beautiful evening. You can see, this is one of his photographs. And for those that are interested, it's at ISO 8000. It's f4. It's a 24 millimeter lens and 30-second exposure. And what you see here is the Milky Way, and we're looking directly south. And while he was doing several images, I was sitting on a rock beside him with my binoculars, and I was observing objects in the night sky. Now, my goal in life, or I should say one of them, is for other people to be able to do what I like to do, and that is to be able to find these deep sky objects that are in the night sky. And just with binoculars, you can find over 60 deep sky objects. And tonight, or this afternoon for some of you people, we're going to find a dozen deep sky objects, and we're going to locate 11 constellations and asterisms. Now, just looking at this picture, you might wonder, well, what am I looking at here? And I put up my binoculars, and I first looked at Jupiter and Saturn. Now, Jupiter, went through binoculars, just round for most people, but I have image stabilized binoculars, so I could clearly see the 4 Galilean moons. And when I looked at Saturn, I could just make out the rings of Saturn with my binoculars. But you have to spend a little bit of extra cash to get that quality of binocular. For the rest of us, you can see a lot of objects with the ordinary binoculars you're going to see in a few minutes. So that included, first of all, you need to find a marker as to where you're going to go. And in the southern, looking to the south in the summertime, that's the teapot. So I'm going to return to this near the end of my talk. But anyway, when I zoom in, what I found here was the Ptolemy open cluster. I found the Butterfly open cluster. I found the M8 Lagoon Nebula. I found the Trifid Nebula. I found the M22 Globular Cluster, M25, and then the Swan Nebula, and finally the Eagle Nebula. I actually found another half dozen objects, but I just don't have time to go through all these. But I'm going to show you this evening how to find each of these with just a pair of binoculars. Because I find that people who try to start observing with telescopes often get very frustrated trying to figure out how to use them and stay on target. But it's very easy to do, to find things and stay on target if you're using binoculars. Now, normally at Nova East and Dark Sky Weekend at Kejmukujik, I set up my binocular table, and this is it. So what you can see here is I would normally have 17 pair of binoculars under a cover so that they don't get dew covered. And on my left side, I would have documents to hand out to people. And so information plus the ACE Amateur Astronomy program certificates. And a typical evening then is everyone grabbing my binoculars, pointing to the sky, and me giving them a tour of the sky. And included in that process is us looking at the list of objects, which is usually about 20 to 22 objects that you can find in the night sky with binoculars at any given time. And the people check, and then I show them how to find things. And in order to complete the certificate, they have to find 5 deep sky objects by themselves. But usually people find 10, 12, up to 15 of them. So it's not a big deal. And I finally sign this off, and people take them home, and they're very happy. And I know many of them actually frame them and put them up because they're so excited, or at least that's what they tell me. Anyway, but I can't do that. So, but on the positive side, I have you now for an hour, because normally I don't have that. So what I'm going to do is I made a little video for the Discovery Center and for the Halifax RASC Center on actually how to use binoculars. So Judy is now going to play that video, and then we'll return to me.
Hi, my name is Tony Schellinck, and I'm an amateur astronomer. I'm a member of the Royal Astronomical Society of Canada, Halifax Center. And this is a short video on the introduction of the use of binoculars to view objects in the night sky. We're going to cover 4 topics. The first is why observe the sky with binoculars, followed by what kind of binoculars should you use? Third, how should I use them? And fourth, what can I see in the night sky with these binoculars? So why binoculars? Well, if you're interested in viewing things in the night sky, RASC recommends highly that you start with binoculars, not a telescope. Now, the reason for that is you can see a lot of objects in the night sky at any given time of the year. But throughout the year, you can probably see 60 or more deep sky objects. So binoculars have a wide field of view. What that means is when you're looking in the sky, it's far easier to actually find the objects that you're looking for. So using binoculars is the best way to learn about the sky and to discover the many objects that you can see that are there. So next question is, what kind of binoculars should you use to view the night sky? Well, the first thing is you don't have to spend a lot of money. There are very good quality binoculars for sale for less than $100. And you know what? The ones you've had sitting at home for the last couple of decades may work just fine. Now, the one thing is people have a desire to buy high magnification telescopes and binoculars. We do not recommend you buy a pair of binoculars that have a magnification over 10. Why? Well, because when you're holding them and they're high magnification, any kind of wobble when you're holding it will show up, and the things you're looking at will disappear when you look through the binoculars. So remember, the magnification should be something either 10 or less. Now, the other thing is that they should be comfortable to lift and to hold. And that again comes to the fact that you want them to be steady. And some binoculars are considerably more heavy than others. So try them out before you leave the store and see if you can hold them comfortably for a little while. And if that's the case, then buy them. If not, then go to a smaller size. There are a wide range of binoculars to choose from. These 3 here are pretty common. This is 10 by 50 binoculars. And what that means is that the opening here is 50 millimeters wide. So we have 2 of those, 50 millimeters each. And it has a magnification of 10. So we say 10 by 50s here. This pair is 8 by 40, so there's an opening of 40 millimeters here. And the smallest pair here I have is 7 by 35s. Normally this is about as small as I would recommend you go. So it has a magnification of 7. Now you might think, oh dear, this is a lower magnification than this one, which it is, but it has certain advantages. With lower magnification, any shapes you may have are not going to affect your viewing that much. And secondly, it has a wider field of view, so it's easier to find things. However, this is an excellent compromise. While this is going to give you higher magnification, so you'll see things closer up, and it has larger openings, so more light is going to come in, so you may be able to see a few more things. This one, 8x40s are relatively lightweight, have good magnification, are a good compromise between these two. But as I said earlier, you want to buy the type of binocular that is easy to hold, something that you can hold up for a while, not too heavy. So how do you actually use the binoculars? Well, there's three things that you have to do. First of all, you have to adjust them for the width of your eyes. If you'll notice, they are hinged. They can go wide or narrow. And when you initially look through them, you may see two different circles, or if they're relatively close, it goes into a figure 8, the kind of thing that you see on television shows and in the movies. But that's not really what you want to see. What you want to see is a single circle. And that way, both of your eyes are aligned with the eyepieces on the binoculars. And once you see that, you know you're set up in terms of how they should be close, they should be together. The second adjustment you have to make to the binoculars is focus. Now, there are two ways to focus a pair of binoculars. The main focus is up here. In this case, it's wheel. Sometimes it's a lever that goes back and forth. But most people don't realize that there's a second way to focus using what's called the diopter. And this lens over here turns. And that focuses this side. So what you want to do first is close your right eye, or else block off the right side and look in the left side like this, and focus on an object that's far away, and then use the main focus to focus on it. And once you get that into sharp focus, then you close your left eye, or cover the left side, and you're going to adjust the focus on this eyepiece. So again, you look through, but you look at the same object, and you focus carefully on it till you get it very sharp. And now what's happened is you focused it for this eye and this eye. And when you look through, everything should be very sharp in what you see. Now, once you've done that, unless someone else changes the focus, you don't have to do it again. All you have to do is use the main focus to look at an object like this, adjust the focus, and you're all set. The third adjustment is for those people who wear glasses. Now, normally, if you're not wearing glasses, you would put you have a cup here, and you would put your eye right up to that cup and push hard against it, and that sets your eyeball at the right distance from the glass in the eyepiece, and you can see everything clearly. And the reason this is raised up like this is because other people who wear glasses would want to roll that down, as we have on here, and when you put on your glasses and look through, that puts your eyeball just the right distance again from the glass in the eyepiece. So this is what you want to do if you're wearing glasses. And if you're not, you want this cup rolled up like that and look through this way. How do you actually find these objects in the sky? Well, there are many star maps that are published, and you can buy them at the local bookstore. There are quite a few apps that you can download for your iPad or cell phone. Monthly magazines on astronomy also generally include a map in the center which shows you what objects are in the sky and how to find them in any given month. What you do is you look at those maps carefully and you see the constellations, and you sort of see where these objects are, and you say, okay, I see some bright stars there, and I know that this object is over here relative to those bright stars. So when you look in the night sky, you'll see those bright stars, and you try to figure out where that object is roughly. Then what you do is you stare at that object. There it is right up there. And the trick is to then not move your head and bring the binoculars right up to your eye. And when you look through, you should be looking at exactly where you think the object is. Now, if it's there, that's great. If it's not there, then, well, you can slowly scan the sky looking for the object, and chances are you're going to find it. We're now going to take a look at what you can see in the night sky with binoculars. I said earlier that you can see a lot of objects, but we'll just talk about 5 of them briefly here. The first one is the moon. You can see a lot of detail through binoculars. That includes craters and seas and other features. And what you should do is you should look along the terminator, because that changes day by day. The terminator is where the shadow on the moon begins, and that highlights a lot of the features on the moon. The next object we're going to talk about, and you can see a sketch of it here, is the Lagoon Nebula. So this is a nebula, and that means it's a whole bunch of gas and dust. And there are stars that are embedded in that nebula that are giving off energy that excites the gas, and it gives off light, and you can see it. So there's lots of nebula to find in the night sky. The next is a galaxy, and this is the Andromeda Galaxy. And it's very large, easy to see, as you can see in this diagram and in this photo. It's our largest, nearest neighbor in terms of a galaxy. It's really exciting if you get a chance to see it. And then we have an open cluster. And again, there's lots of open clusters in the night sky. And what they are is when a nebula has finally collapsed all of that dust and gas to form anywhere from tens to hundreds of stars. And they're all still hanging around each other. And they're all very, very new. And it's kind of cool to see them. The next one is a globular cluster. And they're very different, even though they're called a cluster. They can have 500,000 stars in them, and sometimes more. And they're very closely packed to each other. And they're also very, very old. This one is M22. It's about 12 or more billion years old, which is quite something since the universe itself is only 13.8 billion years old. Well, thank you very much for watching this video. I hope you found the information helpful and inspiring. And may I wish you clear skies.
Okay. So, thank you, Judy.
You're welcome.
Okay, I'm going to share my screen again. No. So, you'll note when I looked at those objects and when I talked about them, I talked about M this and M that. And since most of the bright objects that are easily seen with binoculars were discovered and listed, not always discovered, but at least listed by Charles Messier, we have 110 objects that we say are in the Messier list and in the order of the list. So M1 was the first one he put onto the list, and M31 was the 31st he put on the list. So that's what we're talking about when we talk Messier. And as amateur astronomers, we can't help ourselves. We have to refer to them as Messier this or M that. So here's a good example. Now, I talked about the fact that we were going to travel along the Milky Way highway. But the Milky Way is a galaxy, and I'm often asked, what is a galaxy? So we are in a spiral galaxy. And here are 2 examples of that, M51 on the left and M101 on the right. And what they have in common with us is they have a core. Now, ours happens to be a bar more than a globe, but basically it's there and it has spiral arms. So that's a spiral galaxy, and that's what we have. Now we're looking down at this galaxy, and if you look at M51 on the left, you can see there's blue regions, and that's where a lot of star formation is taking place. But there's also dark brown regions, and that's dust lanes, but you don't see them very well when you're looking straight down from the top. When we look at a couple of other galaxies, there's the Hamburger Galaxy on the left, and there's some M106, the Sombrero on the right. Things are a little different. Now you're looking through the galaxies from the side, and all that dust and gas, you can see it now clearly. And so we would expect, since we're embedded in the middle of one of the arms of our galaxy, that we too would be able to see those dust lanes. And of course we do. So now no one flew outside of our galaxy to take this picture. This is actually a photograph I took of M31 Andromeda, but I'm going to use it as a surrogate for our Milky Way galaxy. And our galaxy is roughly 100,000 light years across. That's an easy number to remember. But where is the sun? Well, the sun is about halfway to the outer suburbs. So 27,000 light years out, we have our sun. Now, in the summertime, when we are out at night looking outside, if we look north, you can see that we're actually looking into the part of the Milky Way that's very thin. There's not a whole lot of stars or not a whole lot going on out there. So we don't expect to see a big, thick Milky Way. When we look up into the sky, we're looking into the arms of the galaxy. And so we would expect to see those lanes that I talked about, those dust lanes. But again, it's not going to be quite as big and bright as if we look south. When we look south, we're looking directly towards the bar that is at the core of our galaxy. And we're looking basically at the vast majority of stars that are in our galaxy. And not only that, the vast majority of everything, nebula and clusters and all that sort of thing, we would expect to see when we look south. Now, so here we have, looking north, the Milky Way. And the Milky Way, you can sort of see it right in the middle of this photograph going straight up. Not a whole lot to see there. But when we look straight up, we get a different point of view. You can see these stars, all these thousands and thousands, or actually billions of stars. Now you can start to clearly see the dust lane. And just to let you know, there's just as many stars where those dust lanes are as they are beside the dust lanes. The difference is the dust is obscuring the light from all those stars. And then we look south. And now what you see here is the Milky Way is expanding. Do you see how it gets bigger as it approaches the horizon? And that's because, of course, we're looking towards the core of the Milky Way. And we would expect that this is where all the action is, and that's the case. So we're going to start our journey. And whenever you're observing the night sky, you always have to orient yourself and figure out where you are. And we do that by looking for the most recognizable asterism that's in the sky. And for us here in the northern hemisphere, that would be the Big Dipper. Now, if you look carefully at this fisheye exposure of the northern sky, you might be able to see the Big Dipper. It's up near the top in the middle. Okay, there it is there. And so why is that important? Well, aside from the fact we can always see it because it's always above the horizon, it has something special about it, which we call the pointer stars. So at the end of the bowl, there are two stars. And if we use them as pointers and go about 5 times down, what we see is that the first bright star we come across is a very important star. It is the Polaris or North Star. Now we know exactly which direction is north. And from there, we can figure out south, east, and west. And so we have our first asterism. Now, you're asking me, what is an asterism? Well, if you look at the Big Dipper, and sometimes it's referred to as the plow in the United Kingdom, it is part of Ursa Major, the Great Bear. Now, the Great Bear is far larger in the sky than is the Big Dipper. But the Big Dipper happens to have 7 very bright stars, and so we give a name to it and call it something, and that's what an asterism is. A bunch of stars, we recognize the pattern, and we give a name to it. So there's the Big Dipper. Then there's the Little Dipper. So how do you find the Little Dipper? Well, the stars are very dim. Judy, can you see my pointer here?
Yep.
You can. Oh, great. So what you want to do is look around and see if you can see 2 bright stars. And if you can, there they are there. So those are at the end of the bowl of the Little Dipper. And now what we're going to do is work our way back to Polaris, which is at the other end, or the end of the handle of the Little Dipper, and there they are. Now, the other 4 stars are relatively dim in the Little Dipper. But if you can see the whole Little Dipper, then you're having a good night for observing. So it's a good test for that. Now we continue past Polaris, come to our first bright star. That's it there. And that is the beginning of another asterism. And this looks like a house. And this is King Cepheus of Ethiopia, featured in Greek mythology. And he is king of his house. So you just have to remember the house shape there. And that is Cepheus. And he was married to Cassiopeia, his queen, and she's right beside him. And she is just a hang a right a little bit, and there she is. Now the asterism here is a W shape. You see that W? And now what we've done is On our list of asterisms, we found 4 of them already. The Big Dipper, Little Dipper, Cepheus, and Cassiopeia. Now we're going to be returning to Cassiopeia because she's a very good pointer to a lot of things. And I just want to point out that when she is in this position, Andromeda Galaxy is under the horizon. We can't see it. But later on in the evening, it's going to go around Polaris and be pointing over this way, and that means Andromeda will be visible to us. All right. So if we look at the Big Dipper, we're going to find our first deep sky object. Now, isn't that exciting? Here we have the Big Dipper, and we're going to look at a double star. It's not a true binary, but it is a famous double star because people with good eyesight can actually make out both of these stars. The name is Mizar and Alcor. Alcor is the little one on top. And here's a close-up view of it. Now, when I show this to young people, they have no problem at all finding that second star. But us oldsters, you know, we have a more difficult time in locating these. And but on a clear night, I can see Alcor. But when you look through binoculars, you're going to see it every time. So that's our first object, is as a double star, is Mizar and Alcor. Don't worry, I have a list at the end of this show and tell you how to find these again.
And Tony, you might want to point out that that double star is in the middle of the handle.
Yes, I'm sorry. This is the handle here, and this is the double star, and you can just make it out there as well. Thank you, Judy. So now we're looking north, and when you look north, you can see this is where the Milky Way is, and if you look through it, you can sort of see 2 blobs. You can see them with the naked eye. They'll be fairly faint, but they're very obvious once you notice them. That's our next deep sky object that we're targeting. But we're going to go and start with, yeah, there they are. What we're going to do is we're going to start with Cassiopeia, because we always want to find bright stars, patterns that will help us locate those deep sky objects. And what you look, when you look at Cassiopeia, you see there's a sharp V or a deep V and a shallow V. So we're going to start with the shallow V and use the center and the other star as pointers here. And we're going to go down 1 and 2, and boom, there we are. We've found the double cluster. And so through binoculars, it will look something like this. So this is 1 cluster here and 1 cluster there. Now, it doesn't look like much here, but scientists are very interested in these clusters because they contain over 300 super blue giants. And those are brand new stars that are maybe only several million years old. And they may be 20 times the size of our sun and over 1,000 times brighter. But they have very, very short lives. And so they're of great interest to scientists to study. And this is a good place to look for them. And there they are there. And now, here's another photograph of them. And you can see that I've got a few more stars showing here. So this is a common target for beginners to see if they can find things in the sky. So hopefully you can do that. Now, that's the double cluster in Perseus. And you know, people say to me, well, what is an open cluster? Well, a nebula and an open cluster are closely tied to each other. So I'm going to kind of show you what they are. Hopefully this will make sense to you. Well, we're going to start off with a star field. So those white dots are stars. And then sometimes, though, when you look at the stars, you'll see what appears to be a large black hole. And we call that a dark nebula. Now, what that actually is a big cloud of gas and dust that is cold. So it's not giving off any light, but it does block the light from the stars behind it. So it looks like this big hole in the sky. So those are dark nebula, but they're true nebula in the sense that they are clouds of dust and gas. But what happens is there's a disturbance in the force, and some of that dust and gas starts to collapse and to form stars. And so what happens is those giant, like super blue giants and other stars, they form in all sizes, start to give off energy. And that energy causes the hydrogen gas that's in the cloud to emit light. And that light is red. And that light, therefore, makes the nebula brighter than the black background of the stars. And that's why we can see a nebula in the sky. So you will see several examples of these red nebula. Then what happens over time is that more and more stars are formed. And over time, those stars are giving off solar winds. And those solar winds blow away the dust and gas that hasn't coalesced into stars. And eventually, what happens is the dust is gone, and what you're left with is an open cluster. So you see the connection between. And it's interesting because some of the nebula we see have a lot of stars that have formed, and you can actually see the open cluster forming. So we're going to go hunting now for some of these interesting objects that are in the sky. But first, I'm going to show you the most interesting and exciting deep sky object that there is in the sky, well, next to Saturn. And that is the Andromeda Galaxy. Now, I want you all to pay careful attention, because for the rest of your lives, you have to find this galaxy and tell other people how to find it, okay? Pay attention. Now, you remember I said there's a shallow V and a deep V in Cassiopeia. Now, this time we're going to use the deep V as if it is an arrowhead pointing to something. And that something is a bright star that's in the Andromeda Galaxy. Sorry, Andromeda constellation. And what we do is, to begin with, we put our binocular on that star and put most of the view back towards Cassiopeia. And that would put that star, in this case, at about 5 o'clock. And then what happens is, given the wide field of view of your binoculars, a second star pops into view around 10 or 11 o'clock. Now, what we want you to do then is, once you have it set up this way, move your eyepiece or your view so that that second star is where the first star was. So you'll move your view up to here. And now a third star, small star, pops into view. It's still pretty bright. And you can see that. But if you look just above it and to the right, you can see a faint fuzziness and a faint cloud all around it. And now you're looking at Andromeda the Galaxy. Now, isn't that easy? Down to the bright star, put it in there, and then move it up so that these two stars are in view, and there it is. So that's an easy thing to remember. Now, the reason I use Cassiopeia as your pointer towards it is, as I showed you before, sometimes this arrow is pointing below the horizon, in which case it's not worthwhile looking for Andromeda. It's only when this arrow is pointing above the horizon that you go looking for Andromeda, and it's relatively easy to find. So what is Andromeda? Yeah, that's how big it really is in this situation, in this picture. So here's Andromeda. Well, how big is that? Because whenever I ask people this question, 19 out of 20 people say they've never seen it. And I go, you've never seen it? It's huge. Just how big is it? Well, here's the size of the moon in the sky. And I know you've all seen the moon. The moon is about half a degree wide in the sky. Andromeda is 8.2 degrees wide. So it's 6 times larger than the moon is in the sky. Now, it's kind of faint around the edges, so you won't see all of it. But you can see a lot of it, even with binoculars. If you allow your eyes to become dark adapted, you can see a lot of these stars that are out here. If there was no interstellar dust and there was no galactic dust, then Andromeda will look this big in the night sky. Isn't that amazing? Unfortunately, the dust is there, but it is a naked eye object. It's about 2.5 million light years away, and you can still see it with the naked eye. Now, I think that's amazing. So once you've figured out where it is using your binoculars, then try and look at it with your naked eye. Use averted vision, will help you somewhat, and you will be able to see it. So that's kind of a cool thing. And remember, you have to tell other people how to find it. So here's the binocular view, and you can see a lot of that fuzziness all around it, the core, and it's there. And all right, that's it. I thought I had a drawing of it, but it's not there. So that's what we can see looking mainly into the northern sky. at or near the Milky Way. Now we're going straight up, and we're going to head south and look straight up into the night sky. So here we see, now when we look here, we can see these dust lanes. And remember, there's just as many stars here as there are over here. It's just that there's a lot of dust there. And the first thing we want to look for, looking straight up, is called the summer triangle. And that is an asterism comprised of 3 bright stars, Deneb, Altair, and Vega. Now, it may be hard to remember that. All you have to remember is the name Dave, okay? So it's D for Deneb, A for Altair, and VE for Vega. So that is a summer triangle, and being up to look up and find it is going to orient yourself as to what is where. So there's several asterisms, constellations, and deep sky objects that can be found up there. So the first thing is the Cygnus the Swan. And Cygnus the Swan has, well, I'll show you what it looks like. So Deneb is a word for tail feather, and it'll come to me in a second. This is the eye of the swan, Albireo, and you can see the wings here. So that's quite obvious when you look in the sky. Now, others call this the Northern Cross. They see this line here and this line here, and they say that asterism for them is the Northern Cross. But we generally refer to it as Cygnus the Swan. Now, I'm going to talk about Albireo more later, so I won't worry about that. Now, we're going to go looking for another asterism, but this is different from the big ones I've shown you. It's a small one that you will really, it's unlikely to see it with the naked eye, although some people claim they can, but you will definitely see it clearly with binoculars. So to find this thing, we draw a straight line from Vega down to Altair mentally, and then we go about 2/3 of the way along that line, and what we see is something called the coat hanger. Now, this is a really cool thing. What it is, okay, that's Albireo, and there's the coat hanger. You see that there are 6 stars there and 4 stars on the hook. Now, I'm told by my students that this is really a pants hanger, not a coat hanger, but we'll let that go. What's amazing is these stars, to our eye, are all about the same magnitude of brightness, yet they're nowhere near each other. Some of them are very far away, but huge stars, and others are much closer, but dimmer stars. So the overall effect is 10 stars that are all roughly the same brightness lined up here and then forming the hook. And it is really cool to see through binoculars. And as you can see here, if you put the hook on the far right side of your view, the Albireo can come into view as well. So here's another photograph of that, and you can see how big, and this is more or less what it looks like when you look through the your eyepiece of your binoculars. And this is, from there to there, is 3 times as wide as the moon. So that gives you an idea that it's quite large. And again, if you hold this, the hook part against the side here, Albireo will just pop into view. Now, I said that young people have better vision than we do. I have, at the Dark Sky Weekend, shown many 10, 15-year-olds Albireo through binoculars, and I test them by saying, can you tell me the color of those stars? And darn it if they don't get it right every time. So this is the color of those stars. Now, through binoculars, apparently, you can make out the super blue giant and the super red giant. But even through the smallest telescope, it's clear to see that they are 2 very different colored stars. And this is important because most people don't realize that stars come in many different colors. And this is an excellent example of how the contrast in colors. And when people are looking for double stars in the skies, the much prized ones to find are those that are very different in color. So that's an exciting part of finding Albireo, the head of the swan. Now, we're going to go hunting for the Canadian star in Lyra. What do I mean by that? Well, you'll see. Well, first of all, remember the summer triangle? And the top of it here has Vega, and it is the constellation Lyra. Looks like a little puppy dog, to my mind. But it is comprised of 6 stars, bright stars, the Asterism. And what we want to do is focus on the triangle that is topped by Vega. And so there we are. This is an easy find for all of us. And you focus on Vega, and then here's the other corners of that triangle. And when we look over here, we see that there is a double star, but it's called the double-double, and I'll tell you why in a minute. But this is cool to see. And I just want you, while we're here, hopefully you can see this, but if you look over at the other corner, that star does not look round. That star looks like a peanut. And the reason is that too is a double star. And it's a true binary in that the stars are orbiting each other. You may, with your binoculars, be able to pick out and separate those 2 stars as well. Now, why is this called the double-double? Well, here they are. I have to take a better photograph of them, but when you have a large telescope and you look at them at high magnification, you can actually split these stars into 2 stars. And so this is why they're called the double-double, because there's two, and they are a true binary in the sense that they are orbiting each other. And so this is the famous double-double, but it's not over yet, folks. Now, in the same constellation, there's another interesting object. It's a planetary nebula, and it's M57 the Ring Nebula. Now, if you look at that, what does that remind you of? Well, it reminds you of a donut, of course. And so if we look at this with I'm going to move these. Oops, sorry. If we look at this, we have the Ring Nebula, or the donut, and we have the double-double. So I think it would be fair for us Canadians to call this the Tim Horton constellation. Haha. Okay, moving right along. There's 88 constellations up there, and some of them are hard to see, some of them are huge, but there's a couple of small ones that are really cool to see through binoculars. And the 2 I'm going to point out are just near Albireo. One is Sagitta the Arrow, and the other is Delphinus the Dolphin. And the reason I like them is because their shape certainly reminds me of the things they're named after. So you can see we have the shaft here and the arrows, the feathers at the end for the arrow. And here you can just picture a dolphin leaping out of water. So those are cool to see, and I have them on my list of constellations to find in the summertime. So now we're going to the south sky. And I'll be another 10 minutes, okay? Is that all right, Judy?
No problem.
You're not going to shut me down?
Not at all.
Okay, good, thank God. Anyway, south sky. Now, I told you this is where all the action is, and you'll see why. Well, we've already looked up here, and now we're looking down here. And what we want to start with always is something, an anchor, or something that we can use to figure out where everything is. And in the southern sky, in the summertime, that is the teapot. Now, the teapot is actually an asterism in Sagittarius. Now, if you're looking at this, I'll brighten it up a bit. There is the teapot. I'll go back. You see those stars there? How that forms the teapot? Okay. Once you see it, it's actually easier to see it in the actual sky. Once you see it, you'll never forget it. Now, this is a teapot, and if you're trying to find it, you have to realize that the steam is coming out of the teapot and going up like this. This bright area here is the steam coming out of the teapot. So that makes it easy to find the teapot. Now, we want to go looking, actually, now that we found that asterism, for deep sky objects. And do the exciting part. And here is a diagram of some of the things that we're going to go looking for. So you can see there's quite a few. Actually, there's about 24, 25 deep sky objects all over here, but we're not going to look at all of those. We'll just pick out some. Now, M6 over here is the butterfly open cluster. So all of the dust and gas has been blown off by these stars. And you can see there's a wing there and a wing there and legs hanging down. Yeah, that looks like a butterfly. So that's the butterfly open cluster. Next, we have the Ptolemy cluster. And this doesn't have a shape of anything, just named after a famous Greek astronomer, philosopher. But it's actually considerably larger than the butterfly and brighter. And it is a naked eye object. So if you can see this, the teapot, and you just come out here, you will see the Ptolemy open cluster, as long as it's above the horizon. So what you do is you can put your binocular view on that bottom of the spout and just move to the right like this. And you can actually fit both M7 and M6 into your view at the same time. So that's kind of cool. And this is my sketch. I tend to sketch everything that I see. It enhances your observing experience. I recommend everyone do it. And people think, oh, well, I don't need to sketch anything. I'm just using binoculars. Not true. You can do a lot of sketching of everything you see just with binoculars. So all of these sketches I'm showing you are done with 10 by 50 binoculars. Pardon me, I bought outbounds from Canadian Tire. And most of them, well, it happened all over. I've been viewing in the States and Hawaii and Europe and South America. And that's the beauty of this. You can go anywhere and view these things. So to find these, you simply go over like that, and there they are. This is the Ptolemy, and this is the butterfly right there. Now, we've found some open clusters. Let's go hunting for some nebula. So the nebula, the dust and gas is still there. It hasn't blown away the dust and gas yet, but we can still see some stars embedded in them. Now we're going to use the teapot again, but now we're going to use the left side of the lid, and it's going to point that way right towards the lagoon and the trifid. So that is the trifid up there, and that is the lagoon down there. So here, we'll have a closer look. There is the trifid, and there is the lagoon. You can see that the lagoon is considerably larger than the trifid and easier to see. Now, this is the Lagoon Nebula. So you can see that it's glowing red, and that's because these stars embedded in it are giving off energy that makes that hydrogen glow red, and that's why we can see it. And in a photograph, you get the color. Looking through binoculars, you never get enough photons coming into your eye to actually see the color. You have to have either an extremely large telescope or a photograph to see the redness of that dust. Now, but it's still cool to see. And now when we look at this, we on the coast here might have a different name for this than the Lagoon Nebula. I personally think it should be called the Lobster Nebula. Now, don't you think that that's a better fit than Lagoon Nebula? I do. So, you know, we can call these things what we want. They're made up names by some people. Anyway, this is the Trifid Nebula.
Tony, that's something to keep your eyes on?
Yes, thank you. This is the Trifid Nebula. This is red because it's an emission nebula, and the gas is giving off light. And this is a cold nebula back here, but it's reflecting the light from this nebula back to us. And we can always tell a reflection nebula because it only reflects the blue part of the spectrum, or blue light. And so we have a red emission nebula and a blue reflection nebula. Isn't that cool? So that's the Trifid Nebula. So here's a photograph, and you can see here we have the lagoon, and in our view, we can also see the Trifid up here. It's a little more difficult to see this. Sometimes you have to use your imagination. Again, this is my sketch of what I saw through 10 by 50 binoculars. Now, so we have seen 2 open clusters and 2 nebula. Now we're going to go hunting for an open cluster and 2 more really cool nebula, M25 and the Swan and Eagle Nebula. So again, we use the teapot, but this time we use the right side of the lid, and we go up roughly that one distance, and we see M25, the open cluster. And then we hang a right at about 45 degrees, and we head up here, and Fortunately, they're both sort of, there's a background of dark dust behind them, so they do stand out very clearly. We see M17 the Swan Nebula and M16 the Eagle Nebula. Now, what's special about them? Well, the Hubble telescope made the Eagle Nebula famous when it took pictures of what it called the pillars of creation. So if you're wondering where the pillars of creation are in the night sky, they're in the Eagle Nebula, and you now can find that easily with your binoculars. The one below it, M16, is called the Swan. Now you might say, okay, where is the Swan? Well, if you look carefully here, it's floating on water, and this is the body. It has a very short neck, and then we have the head here. Looks more like a loon to me, but hey, this is called the Swan Nebula. So there they are, and M25, the open cluster, is down here. So that's 3 more deep sky objects. And I told you, this is where all the action is down south here. And again, here's my sketch of M17 and M16. And yeah, now I've saved the best for last. In my opinion, after the Andromeda Galaxy, this is the coolest thing I like to look at. And the reason is a globular cluster like this, the higher the magnification, the bigger the telescope you have, the more spectacular they are. They're great in binoculars, but I also have a 16-inch telescope that I can boost up to 400x, and I have to tell you, look at an M22 with that is unbelievable. But I'm supposed to be selling binoculars here, so it looks great in binoculars too. Now, what is a globular cluster? These are the oldest things your eyes will ever see. They were formed anywhere from 10 to 12.5 billion years ago. And that's a long time when you consider that the universe itself is only 13.7 billion years old. So they were formed right at the beginning of our universe, at the beginning of time. And they're still hanging around. And they're comprised of anywhere from 500,000 up all the way up to 2 million stars that are so closely bound gravitationally that even huge galaxies like the Milky Way can't rip them apart. But they do like to hang around galaxies. And when we look at our galaxy, the sun is here, and you can see that there's all of these globular clusters. They're not part of our galaxy. They're just hanging around it, orbiting around it, and sort of like flies around dead meat. And so they're kind of cool to see. Now, this is M22, the globular cluster. And these 3 bright stars here are good markers to make sure you're actually looking at the globular cluster. Now, to find it, it's dead easy. Why? Well, again, we use the teapot, but this time we're going to use the top of the lid, and we're going to put our eyepiece right on that. Because the globular cluster, we go look left, and we can see those 3 stars I told you were signposts on the way, and right behind that fuzzy looking star, well, that's the globular cluster. But our eyepiece can keep that top star on the lid in our view, and we can still see, so we won't get lost. We'll still see M22. So this is what it looks like up close. This is the top of the lid in the teapot. Here's our signpost stars, and there is M22. Isn't that easy? Isn't that amazing? I think so. And here is my diagram, my sketch, the star, the signpost stars, and M22, all through my 10 by 50 binoculars. So folks, there you have it, all kinds of things to see. Now, I said it's a summer challenge. I have shown you 11 asterisms and constellations along the way. The Big Dipper, Little Dipper, Cepheus, Cassiopeia, Summer Triangle, Cygnus, Lyra, Sagitta, Delphinus, Coathanger, and Teapot, and 12 deep sky objects: Miser Alcor, Double Cluster, Andromeda Galaxy, the Double Cluster, Double Star, Albireo, Butterfly, Ptolemy, Lagoon, and Trifid, Globular Cluster, M22, M25, and the Eagle and Swan. Well, if you can find even several of those, you'll have accomplished a lot. But it's really not that hard to find all of them in the night sky. Now, one thing you can do, I recommend, if you look down in the lower left here, it says Sky Maps. If you go to skymaps.com, they print off every month a PDF map of the sky. On the back side, it lists all the things you can see with binoculars. I'm not showing you that. And as I say, it's every month. And here you can see we've got Jupiter and Saturn are shown here. And this should look familiar to you by now. There's the Milky Way. And when we look at this, we started off with the Big Dipper, the Little Dipper, Cepheus, Cassiopeia, the Summer Triangle, Cygnus the Swan, Lyra, the Coat Hanger, the Sagitta, Delphinus, and the Teapot. So there they all are shown to you on this map. Now, any magazine will also have this map or something similar to it each month in the middle, the fold-out. In terms of deep sky objects, we started off with Mizar and Alcor. We found the double cluster. Then we found, slightly away from actually the Milky Way, we found M31 Andromeda. And then we came up here and found the double-double, Albireo, and then we started M7, M6, M20, M8, the Lagoon, and M20, the Trifid. There's M22, the Globular Cluster, M25, the Open Cluster, M17, the Swan, and finally, M16, the Eagle. Well, there they all are. And now that you can see them on the map or any map, you know you can use the asterisms that we've identified to help you find them and a pair of binoculars. And after that, it's a piece of cake. So I said my lifetime goal, one of them is to help you do what Colin and I were doing just the other night, enjoying the night sky, using binoculars, finding deep sky objects, appreciating them, observing them carefully, and having a wonderful time. So I hope that this little talk has motivated you. I hope it's informed you, and I'm hoping there was some entertainment as well. So thank you very much.
Well, thanks very much, Tony. It was a super talk as usual. You always pack a lot into a short period of time. I just wanted to let you know that I also spell Albireo wrong most of the time.
Oh, is that right? Thank you for pointing that out.
It's a tough one.
Yeah.
No, that's great, and I forgive you for not even mentioning Messier 11, the flying duck cluster, because that's one of my personal favorites in Scutum.
I considered it. That was my next choice, but yeah.
I know you have a peculiar fascination for Sagittarius, but it is, of course, where the action is. But you know, in the summer, it's tricky to see Sagittarius sometimes because you got to wait up late, and it's quite deep in the south, so you have to find a good observing location where it's dark and there's no trees down there. So anyway, I have one question before we open it up to the audience. Do you really draw your sketches with white on black?
No, I don't. I use ordinary paper and ordinary pencils, and just do them on the spot mostly, and then take a picture of them and convert them, take a negative of that using the picture editor.
That's a very effective way, and it's, you know, makes it look really good, eh?
Yeah.
I'm not sure that people would appreciate that just looking at it, but it's, you could just take a white paper and a you know, a pencil and draw things in reverse, like the stars are dark dots and then the background sky is white, and then you just take a picture and reverse it. It's pretty straightforward.
If you're sketching the moon, you don't do that. You sketch it as you see it. But if it's sketching the sky, you're going to take the reverse. So,
having said that, there haven't been a ton of questions. Well, you must have mesmerized everybody.
Actually.
Was there a question?
No. There
Well,
you
here we go, folks. Before you sign off,
Sleep, or they had no questions.
Yeah.
I have a question. Sorry I was late. I'm kind of new to this group. I'm actually from Winnipeg. So I'm sorry if I came in late, Judy. I'm actually one of the binocular, I guess if you want to call it, gurus in our group. You probably, Tony, you know Jerry Smolensky out of our group. You probably talked to him a couple of times, I'm assuming.
I don't remember doing that, but.
Oh, okay. Wasn't sure. One of the things I was going to mention about binoculars, and I'm sure you're aware of this, but I do a lot of binocular related activities with our club. And one of the big things I try to push is also daytime astronomy with binoculars like Venus, Jupiter in early dusk and things like that. Even some brighter stars sometimes, even with a modest 10 by 50 or 15 by 70 type pair. What do you recommend, I guess, for people that are looking at doing that kind of astronomy as well, besides the moon, obviously? I mean, that's another daytime object.
By that kind of astronomy, you mean looking at planets and whatnot? Or?
Oh, yeah. Like I have 11 pairs, so I have everything from a 8 by 44 to a 25 by 100 pair. So yeah, I've got some pretty big guns as well. I know that's cheating, but, but even with the 10
I see that you came in late because there was a confusion about the timing of this. Did you see the video at the beginning?
I may have missed it. You probably talked a little bit about some of it. I came in kind of midstream just when you hit Lyra there.
I was recommending to people that they, at least initially, not buy binoculars more than 10x, simply because handshaking. And I didn't go into whether you use a tripod to hold things and so on. I have a 15 by 70 and I love it, but it took me quite a while to figure out how to hold it carefully and prop my elbows up so that I can get it good and steady. And once it's a great viewing binocular, but I don't ever recommend to beginners to buy something that powerful because they're going to get very frustrated very quickly.
Carol Morrison has a question, Tony. I'll read it out. She says, stars are moving away from us. Has this altered the view of the night sky?
In our lifetime, no. But yes, the sky changes over time. And so when the Egyptians were building the pyramids, they were lined up with the stars and using the stars. And what they saw in the sky was quite different from what we see. And that's partly because of several factors about the movement of the sun around the galaxy and the Earth, the various motions of the Earth. But even so, the stars, even 1,000 years, would hardly be noticeable that there's any real change in their position relative to each other.
I remember talking to David Turner, who has a special interest in Ursa Major. Those stars are quite close to us and they have high proper motion. In other words, their motion through the sky relative to the other stars is quite high. And he was saying that thousands of years ago, the shape of the constellation looked quite different.
So they are moving. But
they certainly are.
It's a matter of time scale as to whether you'd ever notice a difference. Did that answer your question?
I'm not sure. Maybe Carol could say something.
Judy would have
I think it has.
I don't know. Can you hear me now?
Yes.
Yeah, okay. Sort of. No, I gather that the further you look, the further back in time you're looking, which to me is just incredible. So if you look far enough, I guess you're looking at the beginning of the universe.
Yes.
So
that's more true of the galaxies than the stars in our own galaxy. The galaxies are billions of years, light years away.
Yeah.
So I guess they talk about cosmic dust. if you go way into deep space, which is getting close to the Big Bang.
I think what Dave was saying is when we're looking that far away, you can't see individual stars, and it's hard to see dust. What you see are galaxies, and probably the largest galaxies that were formed at that time, and that's what you can see. You can impugn or guess about other elements that are going on based upon what you see, but you can't. What you actually see, though, is visually large galaxies.
Jerry Black has made a comment of cosmic microwave background. Maybe he could explain that a bit?
I think that's what I'm talking about, I think.
I'd love to be able to explain that, but I can't. But as things have cooled and distances have increased, there is a very, very minute variation in the measurable heat in the background and at the microwave level. This is used in some way, which I don't really know, to explain the expansion of the universe and in reverse. Somebody else can probably explain that better than I can.
Well, it's a little off the topic of tonight's discussion. It might be a better topic for another discussion. But
yeah,
we're talking about what we can see close by tonight. Yeah.
That's
most
right.
all of the things that, except the galaxies, all of the things that Tony has pointed out to look at are inside our own galaxy. The other galaxies are outside of our galaxy, but this has only been known for a relatively short amount of time, like in the 1920s or 30s is when they sorted that out. And before they made those observations, it wasn't clear whether the galaxies or the galactic nebula were not inside our own galaxy. But that was a big breakthrough in observational astronomy. But from our point of view, everything just seems to be plastered on the bowl of the sky, and we don't really see the depth of it. But thinking about all the things that you can see, there's actually an interesting article in the Observer's Handbook by Louise Edwards, and it's called The Deep Sky from Near to Far. And it talks about all the different things that we can see in the sky and their distances from us, which is something which is not obvious. And that most of the things are fuzzy, but they're fuzzy for different reasons. So if you're a member of the RESC and you have your Observer's Handbook, I would recommend reading that article now that you've had Tony's introduction to the night sky. If you want to know more about the physics of it, read Louise's article because it's very good.
Yeah.
Well, you know, I think we've more than done this topic. Thank you very much, Tony.
My pleasure.
An excellent presentation as usual. I'm sure you've inspired everyone to go out and look. Too bad it's thunderstorm watch here tonight, but we made it through. Back to you, Judy.
Okay, well, thank you everyone for coming this evening. A special thank you to the SCANS group for joining us in this session. And certainly, as Dave said earlier, we encourage you to join RASC if so inclined and learn a lot more about what you're seeing up there in the night sky. I really want to thank Tony on a personal note. It's because of him, 7 years ago at the binocular table at my very first Nova East that I had absolutely no interest in attending, but my husband dragged me to. It's because of him and one other gentleman that night that did the sky tour that I developed a love for looking at the night sky. And as a fellow observer once said, it's not only wonderful to look at the night sky, but to also know what it is that you're looking at in that night sky. And Tony, certainly you've shown us all what to look for so we can identify what it is that we're really seeing out there. So I thank you very much.
My pleasure.
Just as a note, next week is Paul Heath, and he'll be talking about walking the solar system. He'll show you how to build your own solar system model and how to go about presenting that as an event that anyone can do. Okay, so join us next week, same time, same station. It'll be announced on our website. It is on our website, Nova's website. It'll also be announced for RASC members through the RASC What's New This Week that Jenna Hines puts out every Monday, I believe. And so keep looking up, keep sketching what you see when you look up, and we'll see you next week.
Thanks, Judy.
Bye-bye.